Okay, now we are starting with still on how to calculate the reaction at the end of a beam. We are going to solve a lot of examples so that you get used to this. So let's start with example 1. So you can pause the video and use the previous knowledge to try this. Maybe you get the answer. So thank you. Okay, so now this is a simply supported beam. So the this one is having an hinge support, this one is having a rolling support. So you know the next step you need to do is what? You draw your free body diagram. So you draw a free body diagram, you draw your straight line. This is the beam, right? So let's draw the beam first. This one is a hinge support. What happened at the hinge support? It's having how many reactions? It's having 2 reactions, which is what? Horizontal and what? Vertical. You get that? But this is a rolling support. How many reactions does a rolling support has? It has 1 reaction. You get that? You get that? So now this one is our what? Point A. This one is our what? Point B. This one is our vertical reaction at point A. This one is our vertical reaction at point B. And this one is our horizontal reaction at what? Point A. You get that? Okay. So now the load itself is what? 50 kilonewton. So it's acting at the what? At the center of the beam. So this is it. So these are 50 kilonewton, and it will act at the center. So if it is acting at the center, it means from this point to this point it's going to be what? 25. Sorry, it's a mistake. The total length of the beam is 8 meters. Sorry. So the total length of the beam is what? 8 meters. If the width is acting at the center of the beam, it means from this point to this point it's going to be what? 4 meters. And from this point to this point it's going to be what? 4 meters. Do you get that? Okay. So now what is our next step? Now since we are done with the free body diagram, you need to draw this. Do you get that? Okay. So now the next thing now is to sum our what? Upward force to be equals to what? Downward force. So it means sum of upward force equals to downward force. I don't need to be writing much note. It's just the same step with the previous class. So this is, you just say sum of upward force, and we have how many upward force here? 1 and what? 2. Do you get that? So now it means ROA plus ROB will be equals to what? Will be equals to W, but our W here is what? 50 kilonewton. You get that? So now the next thing you need to do, but I want to ask you a question. If this 50 comes back here, it will be what? Negative. It means our coordinate, our upward force is what? Positive, while downward force is what? Negative. Upward force is positive, while downward force is what? Negative. Take note of that. So now you call this on your equation what? 1. The next thing is you take your moment. You can take it about any point, maybe point A or point what? B. Do you get that? So now let's take the moment about what? Point A. Do you get that? So, and don't forget, if we take the moment about point A, the moment at point A will be equals to what? 0. Do you get that? So if we take the moment about here, so I'll put my hand here. How many forces are we having? We'll be having 1 and 2 forces. Do you get that? So now we'll be having ROB, and it's going to go, and you know moment is what? Force times perpendicular distance. This is perpendicular, 90 degrees. This is also what? 90 degrees. Do you get that? So that's the meaning of what? Perpendicular. So it means ROB times what? Total distance that it covers before when reaching what? A. Do you get that? This is the point I'm taking my moment. So all this must come to what? This point A, the forces. Do you get that? So now ROB times what? The perpendicular distance. And what is this upward force here? Is what? Positive. And this one is 2 is what? Upward force. So it means ROB times what? The total length, which is what? 8. So it means ROB times 8. Now this is a downward what? Force. Downward force, which is what? Negative. Negative. And it is what? 50 times what? Perpendicular distance. What is the distance from here to here is what? 4. It's going to be 50 times 4. Do you understand? Which is equals to what? 0. Don't forget, we take the moment about what? Point A. So you can say moment about point A is equals to what? 0. Do you get that? So these are the moments, everything equals to what? 0. Do you get that? So now, RB times 8 is what? 8 RB. 50 times 4 is nothing but what? It's nothing but what? 200. It's nothing but 200. Which is equals to what? 0. Do you understand? So this 200 will come back here. We are going to have 8 RB equals to what? 200. So for us to get our RB, what are we going to do? We divide both sides by what? By 8. So RB is equals to what? 200 over 8. And 200 over 8 is what? You can just use your this thing. 2 here, 2 is what? Is 10, right? So we are going to have 100. 2 in 4 is what? 2. 2 in 100 is what? 50, right? 2 here 1, 2 here 25. Do you get that? So ROB is equals to what? 25. You can just use your calculator. Just use your calculator to press 200 divided by what? 8. Then you get your what? 25. But note that this weight is in what? Kilonewton. Do you get that? So this one too will be in what? Kilonewton. So now, can we get our RA now? Yes, from equation 1 now. RA plus ROB is equals to what? Is equals to 50. So now ROA, what is our ROB is what? 25 equals to what? 50. I substitute 25 for ROB in this equation, equation 1. So now ROA now will be equals to what? 50 minus what? 25. And ROA is equals to what? 25 kilonewton. You get that? The sum of upward force is equals to downward force. Yes, you can check that again. ROA plus ROB. 25 plus 25 is what? 50. So this side will be 50, this side will be 50. It shows that the beam is at what? Equilibrium. It shows that our working is what? Correct. So this is how to check maybe what you have done is what? Correct. Thank you and God bless.